Okay, one of the early topics of review is just dealing with factoring. So some of the key steps when you're looking at factoring is first thing, see if there's anything in common. Like common factors would be like everything's even, or you have an X you can pull out. So try to factor out common terms to start. And then it's always a good idea to look for special cases, particularly after factoring. You only see two terms. So a real common one to look for is difference of squares. And then our big issue we're going to try to do is let's look at factoring trinomials. So let's look at a basic example to start. Right here, we have just two terms. So I'm looking at the 27, and I'm looking at 75. And if I notice, 3 will go into 27, 3 will go into 75, and I have x to the fourth and x squared. They both have at least two x's. So I'm going to factor out an x squared, and I'm going to factor out a 3. So I took out 3x squared. Now 3 times 9 gives me 27. X squared times x squared gives me x to the fourth. And then 3 times 25 gives me 75. So that's why I put 25 here. Negative just carries down. And then x squared times, of course, 3x squared times 25 will give me negative 75x squared. Now this is a special case of difference of two squares. If you recognize the form, which you should realize that this will factor to 3x plus 5 and 3x minus 5. Now to see why, one of the common things we'll use is just use a generic rectangle. So I'm going to show you why this basically works by placing the 9x squared into this spot and negative 25 in this spot. Now normally what we would do is multiply these two together, and that would give me like negative 225x squared, and I'd write it down in this spot down here, right in this area. But this one is difference of squares. I'm going to show you kind of what happens when you look at the rectangle and what happens with our middle terms. Well, I get 3x times 3x give me 9x squared. And I have positive 5 times negative 5 will give me negative 25. When I calculate this square in here, I get 3x times 5, that gives me 15x. 3x times negative 5 gives me negative 15x. When I add these two terms together, they sum to 0. That's why there's no middle term. Now that's a lot of extra work just simply to memorize that little fact. If you have a difference of two squares, 9x squared is a perfect square, 25 is a perfect square. So I take basically the square root of 9x squared, I get 3x. Square root of 25, I get 5. Do 3x plus 5, 3x minus 5. So one positive, one negative. So those ones should be the simplest ones to recognize and easiest ones to factor. Okay, let's look at one that's not quite as easy to factor. So in this case, I don't have any common terms. You may see the 6 and 3, they have something in common, but there's nothing in common with the 7. I have x squared x, but there's no x's here, so I can't factor out any common terms. So this is really dealing with how do I factor that trinomial. So one of the easiest ways of doing this is to use a generic rectangle. So I'm going to take the 6x squared and put it into this upper corner here. I'll place negative 3 in the lower corner. We multiply these two terms together, the 6x squared times negative 3. That gives me negative 18x squared. So when I multiply these two together, they're also going to multiply to give me negative 18x squared. But they need to add to give me negative 7x. So I need two numbers, and kind of pay attention just to the negative 18. I need two numbers that multiply to give me negative 18, but add to give me negative 7. Well, if I did 2 times negative 9, they multiply to give me negative 18, but 2 plus negative 9, that gives me negative 7. So what I really have is going to be a 2x and negative 9x. So I have to put negative 9x up in this corner and 2x down here. So I got two numbers that multiplied to give me negative 18x squared, but they added to give me negative 7x. Okay, now to find what goes on the outside. Some of you are really good at just looking at it and be able to figure out the terms, but this really works. I could factor up and factor across. So long as I factored out my common terms to start, this is pretty much going to work. So 6x squared and 2x, they have an x in common, and they are both even. So I factor out 2x. Look in this direction. Okay, 6x squared and negative 9x. They both have an x. They're both are multiples of 3, so I can factor out 3x. Then I say to myself, okay, what do I multiply by? Well, to get this one, 3x times something will give me negative 9x. So 3x times negative 3. And then over here, I have 2x times something will equal 2x, plus 2x times 1. And then my check ends up being negative 3 times positive 1 has to equal negative 3. That one works, then you did everything correctly. So that tells me this factors to 2x minus 3 times 3x plus 1. Now, it doesn't matter the order. You could have done 3x plus 1 times 2x minus 3. That would have worked as well. Okay, let's kind of put all the pieces together now. Okay, so first step is look for common terms. So I have x's and y's and everything. They're all even. So I could take out 2. And then look at x. I have x cubed, x squared. I have 1x. They all have each at least 1x. Then I go to my y's. Okay, they all have a y. Okay, so that's what I'm going to factor out. So I'm going to take out the 2xy. That's going to leave me 2 times 9 x squared. So I took out one of the x's, took out all the y's. For the next term, I'd have 2 times 12, so that needs to be 12. I took out an x, so I still have an x left over. Took out the y, so it's gone. Then I have 2xy. I took out the x and the y, so 2 times 4. Okay, so now let's look at our rectangle. Some might recognize this is a special kind of a case also. If you recognize it, great. If not, this box technique works. So 9x squared in the corner, 4 in the other corner. 9x squared times 4 is 36x squared. I need 2 terms to go in here that will multiply to give me 36x squared. They're going to multiply to give me 36x squared, but they have to add to give me 12x. Well, this one's a little easier to see because 6x plus 6x will give me 12x. 6x times 6x is 36x squared. So I got the same number. And that's kind of that special case that you may have seen before, which is perfect square trinomials. Let's get rid of those. Okay, so now, again, I'm going to factor. So if I went up again, 9x squared and 6x, kind of factoring upward. They're both got an x, and both are multiples of 3. So I have 3x up at the top. Factor out this direction. I also get 3x. It's basically the same problem. Then 3x times 2 will give me 6x. 3x times 2 in this direction is 6x. Then, of course, 2 times 2 is 4. That's my check, so I know it's correct. So it's 3x plus 2 and 3x plus 2. Now, this is the pattern when you have a perfect square. You might see it also written in this format. When you're squaring a binomial, it is going to be first term times itself. So 3x times 3x is 9x squared. Multiply these two together at 6x and then double it. That's what the 12x is. And 2 times 2 is 4. So if you recognize that one as the perfect square trinomial, it could have saved you the step with the rectangle. but the rectangle method still works. Now, sometimes numbers can get really big, and it might be hard. It might be easier just to do a guess and check to figure out what goes in the boxes. Okay, hopefully that helps out.